Thank you very much for introducing me. Good afternoon. I'm Sasaki from Electric Power Company. It's my pleasure to have the opportunity to speak about our company's activity. Thank you. So, today, my presentation is demand-side technologies of electric power company. Let's start my presentation. First, I would like to talk about TEPCO. TEPCO is the biggest electricity company in Japan. The revenue is about 55 billion US dollar. Well, our service area is around Tokyo, or center of Japan. Well, this is our target and initiative. Well, 2030 target is reduce 50% and 55 challenge reduce CO2 emission from supply of energy to net zero. Well, we have to work supply sector and demand side sector and grid sector. So this is TEPCO holding structure. After the regulation, TEPCO split into several companies. TEPCO Holding has Fukushima nuclear power plant, and we have thermal power plant, grid company, retail company, and renewable energy company. Well, energy partner is retail company. I belong in energy partner. I have been in charge of research and development of customer side facility and services. Well, as I said, energy partner supplies electricity and gas, and we also offer energy facility services. We install our own facility in our customers' building to provide heat and power. It's one of subscription service. We also provide ESCO services that guarantee energy saving. Well, this service is provided by our subsidiary, JFS. We provide energy facility services to more than 190 customers. Well, generally speaking, electrification in industrial sector is difficult. This case is electrification on the painting process. Heat pump improve energy efficiency and reduce CO2 emission. The system utilizes hot waste heat from air compressor operation and cold water production. Well, we are in the process of redeveloping the area that includes our headquarters. This plan has world's first high-rise buildings to implement mega solar power generation with perovskite solar cell. We don't use PV on the window. Well, this is the impact of solar power expansion. As renewable energy increases, thermal power plants decrease. Thermal power plants are easy to control. So thermal power plants are responsible for grid power stabilization. In the future, thermal power plants alone may not be able to keep the grid power stabilization. Well, this is a big problem for power company. So when the share of variable renewable energy is large, a large supply-demand adjustment capacity is required to stabilize the grid electricity. Well, we have 5 means. First, suspension of variable renewable generation. Second, very low operating thermal power plants. Third, pumped storage. Fourth, battery storage. Fifth, demand response ready equipment. Just add demand response control functions to heat pumps. Well, all 5 options are important, and DR ready equipment is the most cost effective. This is an image of a virtual power plant for demand response. Virtual power plant and demand response are that aggregators control the facility in each buildings. Electricity power companies buy changes in the power load of each building. Well, this is a residential sector. Even if disaster cases grid power outage, we will be able to continue our lives. We offer subscription services for these expensive facilities. This is the world's first heat pump water heater using natural refrigerant. Why has power company developed water heaters? Well, these heat pumps are different from European and US equipment. EcoCute controls the electricity consumption during the hours of low electricity load on the grid. It is the point is a different point from European and US equipment. Now, total sales in Japan have reached 9 million units. And we developed PV-driven EcoCute with manufacture in 2022. This EcoCute uses 2 renewable energy sources, solar power and ambient heat. So we can use PV generated electricity. This is the Harumi Island district heating cooling system. This DHC has a huge water thermal storage tank underground. Now we are challenging demand response demonstration based on grid supply and demand conditions. This is visualizing detailed energy usage is fundamental to energy saving activities. We offer visualization services, and the service can be offered as a set with a demand response contract. Well, packaged air conditioning units are used in small and medium-sized buildings in Japan. We offer air conditioning control services too. This is a future image. Energy management system platform is critical for us to effectively utilize virtual power plant and demand response by DR-ready equipment. Of course, storage batteries are also an important tool for demand response. And we think EVs charging and discharging demonstration for demand response, where this EV is for companies EV, not private EV. This is green hydrogen production demonstration. The demonstration is also challenging demand response operating. This is central plant for green hydrogen production. Well, we are developing a demand-side hydrogen generator. This hydrogen generator is installed our customer's factory. So I have two conclusions today. First, political decision change private sector activities. Well, of course, demand side activity are selected for cost effective, and heat pump are effective for low temperature heat below 100 degrees Celsius. Green hydrogen is more advantageous for high temperature heat. Heat pump can reduce CO2 emission, but heat pump are more expensive than boiler with simple structures. Initial investment reduction through subscriptions are effective in expanding the IFC equipment with a long payback period. And subsidies for equipment and manufacturers and bans on combustion equipment and higher fossil fuel prices due to carbon taxes. These policy contribute to increasing in heat pumps. Well, next conclusion is demand response. Development of IT technology has made it possible to effectively use the thermal storage heat pump and the change temperature setting of the air conditioner. The DR will contribute to the expansion of the ratio of renewable energy. It is cost effective to add DR function to demand-side equipment at the time of renewal due to aging. On the other hand, next renewal takes more than 10 years. So efforts for early expansion of demand response are needed. It is also important to promote global standardization of communication protocol and DR function. Well, at COP28, many countries committed to the IA recommendations, triple renewable energy, doubling energy efficiency. We think that smart electrification with flexibility is key technology to contribute to both goals. Thank you for your attention.